Good morning guys. Today we are going to discuss about the Michelson-Morley experiment. Michelson-Morley experiment. It was a scientific experiment to find the presence and properties of substance called ether, a substance believed to fill empty space. The experiment was done by Albert Michelson and Edward Morley in 1887. Since waves in water need something to move in water and sound waves as well as air, it was believed that light also needed something to move in. Scientists in the 18th century named the substance ether after the Greek god of light. They believed that ether was all around us and that this also filled the vacuum of space. Michelson and Morley created this experiment to try and prove the theory that ether existed. They did this with a device called an interferometer. Aim of this experiment. Michelson-Morley experiment was done to confirm the presence of hypothetical medium called ether. The main objective of the Michelson-Morley experiment was to check the presence of the medium called ether. The aim was supposed to be fulfilled by measuring the velocity of the earth with respect to the ether. If earth is supposed to be propagating through the stationary ether with a uniform velocity, and if a beam of light is sent from source to observe towards the direction of the motion of the earth, then it should take more time if sent through the opposite direction. If the time difference can be measured, then velocity of earth with respect to ether can be measured. Experimental arrangement. The light is emitted from the source S and is inclined on a collimating lens L. The lens L will make the light parallel and the beam will now incident on a plane P, which is inclined at an angle of 45 degree. The P will divide the light into two parts, one reflected ray and one other transmission beam. The reflected beam will incident on mirror M1, transmitted on M2. Separation between the P and M1 and P M2 is same, and that is equal to I suppose, and the separation is called the length of the arm. The light will reflect back from mirror M1 and M2 respectively and will interfere at P. The interference pattern is noticed by telescope T. This is the experiment setup. Coherent light source, and it follows the semi-silvered mirror, and then it transmitted to the mirror and then reflected to the another mirror. And it is this both rays are coincide in the interference pattern we see here using the detector. Derivation. As the observer is assumed to be an ether and is study the motion of the earth with respect to ether, thus a light beam which incident on P and reflect toward M1. It will catch the M1 at new position M-1 at B according to Michelson-Morley. Then the light reflected to P at C. Here all of the apparatus are assumed to be moving with the speed of the earth, that is B, and speed of light is C, as A and B is more distant than A to P dash. Even then the light will catch the M-1 at the same time as from A to P dash. This is because C is greater than P. Thus the light taken for light to reach at M-1 and for P to reach at P dash will be taken same as T. Calculation for time taken for reflected path, that is from A to B and then B to C. Take a triangle AB P dash and apply Pythagoras theorem. AB square equal to BP dash square plus AP dash square, where AB is the path covered by light in time t and AB dash is path covered by the plate P in same time t. BP dash the length of the arm, that is equal to I. Thus the equation becomes C square T square equal to I square plus V square T square, or T square and the V square T square is taken this left hand side and then take common T square, then become C square minus V square equal to I square. T square equal to I square, then this taken into the downwards I square divided by C square minus V square, and then T square equal to I square by C square of 1 minus V square by C square. T equal to 1 by C of 1 minus V square by C square whole power of, because this is under it minus and then mal, and then it's go up become 1 by 2, or T is equal to 1 I of 1 minus V square by C square into minus 1 by half by C. Applying binomial theorem neglect higher terms and then become the negative sign in this previous slides, it become positive here. This is the time taken by light from A to B. Same time will be taken from B to C. Therefore, total time for the reflected path will be T1 equal to 2t or T L equal to 2 I of 1 plus V square by 2C square by C. Calculation for time taken for transmitted path, that is from A to M2 dash and then M2 dash to A. As the apparatus and the light both are moving in same direction, that is when light is going towards M2 dash, thus the relative velocity will be C minus V. After reflection, the apparatus and the light both are moving in the opposite direction, that is when light is going towards B. Thus the relative velocity will be C plus V. Thus the time taken from A to M2 dash and from M2 dash to C will be T2 equal to 1 by C minus V plus 1 by C plus V. Further solving, we get 2I in 1 minus V square by C square inverse divided by C. Applying binomial theorem to the RHS and neglect higher terms, we get T square is equal to 2I into 1 plus V square by C square divided by C. Before we done that, like again we want to do here. Therefore, the time difference between the transmitted and reflected rays will be del T equal to T2 minus T1. Put equation 1 and 2. Del T equal to 1 LB square by C cube. Path difference for the transmitted and reflected ray will be del into 1 equal to C into del T equal to C LB square by C cube, or del cross L equal to 1 L square LB square by C cube. Equation 3. After this experiment is rotated through 90 degree, so the mirror will exchange their positions and path difference is again calculated. It will come out del cross 2 is equal to 1 minus 1 V square by C square. Therefore, total path difference will be del in X equal to del into 2 minus del into 1, 2 LB square by C square. 5. This is equation 5. Then the number of fringes shifted is calculated by following relation. Fringes are the pattern obtained by interference of two more rays, that is by constructive and destructive interference. N equal to path difference by wavelength of light. N equal to del x by lambda. Put equation 5. N equal to 2 LV square by C square lambda. Then N is calculated by putting L equal to 11 meter, V is equal to something. Then the fringes become, we assume that become L equal to 11 meters, V equal to 3 × 10⁴ meters per second, C is equal to N is calculated by putting these values, and then we get N equal to 0.37 fringes. But experimentally N equal to 0. Thus the theory and experiment result are not matched, but the experiment was right. So there was some problem in theory calculation. Different scientists tried to explain this negative result of Michelson-Morley experiment. Conclusion: there is no role of any material medium for its propagation, that's light. Light does not propagate as a longitudinal wave. The assumption of existence of either medium is wrong. Velocity of light is independent of motion of a source or medium or observed. Velocity of light is same in all direction. Thank you for visiting this video.